Before discussing the derivatives of inverse trig functions, we should review how the inverse trig functions work. We'll focus on sine of x first. Remember that the graph of the inverse of a function is flipped across the line y equals x, since we flipped the x and the y values. Because the inverse function needs to pass the vertical line test, this means that we can only take the part of the original function which passes the horizontal line test. So if we start at x equals 0, we can only travel to x equals pi over 2. This only covers the range from 0 to 1. To get the rest of the range, we move backwards to minus pi over 2. So when we flip the graph to get the inverse function of sine of x, the domain is from minus 1 to 1, and the range is from minus pi over 2 to pi over 2. This is called the inverse sine function, denoted either as sine to minus 1 of x or arc sine of x. Arc sine and sine are related in the following way. We say that y equals arc sine of x, or inverse sine of x, if and only if sine of y equals x, and y is bounded between minus pi over 2 and pi over 2. For example, if we want to compute arc sine of 1/2, we set this equal to y and then rearrange. Y must be the value so that sine of y equals 1/2, where y is a value between minus pi over 2 and pi over 2. Drawing a quick unit circle, we see that y must equal pi over 6. Similarly, if we want to compute arc sine of minus 1/2, we set this equal to y to get sine of y equals minus 1/2, where y is a value between minus pi over 2 and pi over 2. Drawing the unit circle, we see that we're in the fourth quadrant for this, which means y is negative. Y must equal minus pi over 6 for this to work. We can do a similar argument for cosine of x. Since we needed to pass the horizontal line test, we let the values run from 0 to pi in this case. Now when we flip cosine of x to get arc cosine of x, the domain of arc cosine of x is from minus 1 to 1, and the range is from 0 to pi. Now we say that y equals arc cosine of x, or if you'd like, inverse cosine of x, if and only if cosine of y equals x and y is bounded between 0 and pi. Finally, we look at the tangent function. If we select the piece of it from minus pi over 2 to pi over 2, we see that this passes the horizontal line test. This piece has two vertical asymptotes at x equals minus pi over 2 and x equals pi over 2. When we flip, we get two horizontal asymptotes at y equals minus pi over 2 and y equals pi over 2. Notice now that the domain is all real numbers. So, y equals arctan of x, or inverse tangent of x, if and only if tangent of y equals x and y is bounded between minus pi over 2 and pi over 2.